16, isn't it? So what is Q? You divide both sides by 20 to get to Q. It means Q. The mean and variance of a binomial distribution is 20 and 16 respectively. Determine the number of trials involved and the probability of success and failure. Now, to handle this kind of case, you simply go by definition. In a binomial distribution, it's a case when you only have two possibilities, isn't it? Happening n number of times, and those number of times are the trials, isn't it? So if you have two possibilities, P and Q, then one is the success, and the other one is the failure. Is the failure, isn't it? The other one is the failure. Failure. That's the spelling. The other one is the failure. So spelling is not the case here. The case is to do the right thing, isn't it? So we now have the mean. A binomial distribution is given by P plus Q raised to the power n. That whole probability is 1, isn't it? So we said the mean of a binomial distribution is given by NP, isn't it?
Yes.
Are you clear? And the variance of a binomial distribution we said is NPQ, isn't it? Where n is the number of trials, isn't it? And we say this is the success, failure, this is a failure, isn't it? It is U, isn't it? Failure, okay. So when you start substituting n and the number of trials, then P, success, then Q, failure. Good, yes. So we substitute what is given to get what is not given, isn't it? What have you been given? You've been given the mean to be 20 and the variance to be 16, respectively, isn't it? So where there is mean, you equate it to 20. So this implies that NP is equals to 20 and NPQ is equals to 16, isn't it? So from there, you can see from there, you found the failure, Q, isn't it? The other one is probability. So NP is 20, NPQ is 16. Those can form two equations, equation 1 and equation 2. The best method here is substitution, isn't it? Meaning where there is NP, you put 20. So it means 20Q is equal to 16, isn't it? So what is Q? You divide both sides by 20 to get to Q. It means Q is 16 over 20. If you divide both sides by 20, isn't it? So what is 16 over 20? 4 over 5. So if Q is 4 over 5, what do you want? The first thing you want is the number of trials involved, n, isn't it? The number of trials involved. So for you to get n, it means we need to get P, isn't it? You can see NP is 20, and what is P? See the probability, the range of probability measure is 1. So if Q is 4 over 5, then it means P is 1 over. Because in binomial there are only two possibilities, P must add up to 1, isn't it? So we have P is 1 over 5. So what is the number? The number of trials involved. So the number of trials involved n, we have here NP is equals to 20. Meaning n is 20 divided by P, isn't it? So what is n? 20 divided by P, 20 divided by 1 over 5, you get 100, isn't it? 20 divided by P, 20 divided by 1 over 5 is 100. So you found the number of trials to be 100. Then the probability of success and failure, you found success 1 over 5, failure 4 over 5, isn't it? Remember, P is usually considered as the initial condition, and the initial condition can be used to denote the success, and that is used to denote the null hypothesis in that order, isn't it? So that is what was expected of you in that given problem. All you need to know is how do we get the mean of a binomial distribution? By definition, how do you get the variance of a binomial distribution? by definition, then from there you just equate the problems, then you'll be able to get what is required.